Okay, Shiza, till the time other students are joining, we had discussed, we had one class, I remember, and we just discussed the basics of inertia. Am I correct?
Yes, ma'am.
Okay, let us go further. So, Shiza, see, inertia we have discussed, and we had discussed that it's basically the inability of the body to change its state of rest or uniform motion. Okay, now Newton's first law was the same, which was the law of inertia itself, that the body will maintain its inertia unless an external force is applied on the body. And types of inertia we had seen: inertia of rest, inertia of motion, inertia of direction. Till here, have you written everything?
Yes, ma'am.
Okay, let's go further then. Now, see, Shiza, in the Newton's first law, we have discussed that body will maintain its inertia unless an external force is applied. Now we have to focus on this external force. What exactly this external force is depending upon. Okay. So before that, we have a concept of momentum. Now, momentum means the amount of motion in a body. Suppose you are running out from a moving bus. So you tend to move a bit. Why? Because there is excess motion left in your body. That amount of motion in the body is known as momentum. Okay. So basically, momentum is the product of mass and velocity. P is the symbol for momentum. P is the symbol for momentum, M for mass, you already know, and V for velocity. So this mass is a scalar quantity. Velocity is a vector quantity. So scalar getting multiplied to a vector gives us vector. Okay. So this is basically momentum. So mass of the body, velocity of the body, and this is momentum. So you can say by definition, it is the amount of motion left in the body or the excess motion in the body. Whereas when you have the formula, you say P is equal to M into V. So it's a vector quantity. And the direction is same as that of the velocity. If the body's velocity is in left direction, so momentum will also be towards the left. Because see, mass has no direction. It's a scalar quantity. So it is, momentum is directly depending upon the velocity V. Okay, so it's depending directly on the velocity. And SI unit is very simple. See, mass is kg, velocity is meter per second. So this becomes kg meter per second. Now, one more thing, when you have this, let's look at a very easy formula and a numerical. This says a body of mass 10 kg is moving with a velocity of 5 meter per second. So this is the mass 10 kg, this is the velocity 5 meter per second. You have to calculate its momentum. So mass is 10, V is 5. So 10 into 5 is simply 50 kg meter per second. Now, one more thing. Yes,
Excuse me,
Shiza.
ma'am.
Yes, say. Yes, Shiza, say. You are asking something? Are you asking something? Hello?
Hello, ma'am.
Yes, Shiza.
Yeah, ma'am. Your voice was breaking, ma'am, so I just rejoined.
Okay. Now it's better?
Yes, ma'am.
Okay, I couldn't hear you. Okay, that's fine then. Yeah, you were asking something?
No, ma'am, I was just saying that your voice was breaking
Okay.
earlier.
Okay. Shiza, I just forgot how much syllabus portion you had informed me in the last class.
Yes, ma'am. Just a second. Ma'am, the how much portion is covered, or else what is the portion for the UT2, ma'am?
UTs, the tests which are coming.
Yeah, yes, ma'am. Ma'am, it is motion in a plane and laws of motion.
Okay, so that's good. Then laws of motion we are covering, and then motion in a plane I'll discuss with you. Shiza, when is the exam? That also let me know.
15th of August, ma'am.
Oh, 15th of
Sorry,
August.
ma'am. Sorry, ma'am. 15th of September.
Okay.
Yeah.
Okay, that's fine. Okay. So yes, I was saying that momentum is basically the excess motion present in a body, the excess amount of motion present. And the formula is very simple. Formula is simply mass into velocity. So since you know mass is a scalar quantity, velocity is a vector quantity. So momentum is directly dependent on the velocity. So direction of velocity, it will be exactly the direction of momentum. And SI units are also easy. Mass is kg, velocity is meter per second. So kg, meter per second. So it's a very easy question, this one. And one more thing before we go to the Newton's second law. Momentum keeps on changing. Why? Because inertia keeps on changing. See, if F external is non-zero, your momentum will change. And if the inertia is changing, your momentum will change. So this can come as a two-marker conceptual question that when can a momentum change? So two things you should know: when can a momentum change? When F external is zero, when inertia is changing. Write it till here and text me done in the chat column, then I'll move further.
Yes, ma'am.
Okay, done. Then let's move to the Newton's second law. Sorry. So yes, as I was saying that Newton's first law is based upon this external force which is coming and changing the inertia. Right, that's what we have discussed, that body will maintain its inertia until the external force is applied. Now let us discuss what is exactly this external force. So Newton's second law is based upon the external force only. So this external force says that, see, this Newton's second law says that it's the relation to measure force. External force acting on the body is directly proportional to rate of change of momentum. Class, whenever the term rate comes, rate means, see, two terms you will come across. One is rate, one is gradient. When something is changing with respect to time, we say it's the rate of change. Like velocity. Velocity is displacement by time, so it's rate of change of displacement. Or acceleration, it's velocity by time, so rate of change of velocity. So rate will come when you have time in your calculation. Gradient means position, something which is changing with respect to position. So right now, which word is mentioned? Right now it is rate mentioned, right? Means momentum, rate of change of momentum. Rate of change of momentum means the momentum which is changing with respect to time. So delta P over delta T, or you can say F external over FT. Yes, Laika, you're asking something?
No, ma'am.
Okay. So F external is dP over dt. dP, now the question comes when to use delta P by delta T, when to use dP over dt, that I will tell you later. So what is rate? Rate is change in time, and P is the change in momentum, T is the change in time. You can ignore this right now. I'll tell you this. Yeah. See, when to use, the main question that arises is when to use delta P by delta T and when to use dP over dt. So whenever you have a duration means what? If I say T is equal to 3 seconds to 4 seconds, that's a duration. And if I say on the other hand, time is 0.00034 seconds, this is an exact instant of time. So when you have the duration, you use the average formula. Average formula means delta P by delta T. Means final momentum minus initial momentum divided by final time minus initial time. And in instantaneous, you differentiate it when you are asked to write about a particular instant of time. Okay, exactly about an instant of time, when you have to write that time, you will be using differentiation. Okay, now regarding this, let me explain you this. I have to explain this again because it won't be clear with this. Now, class, whenever we are studying force, there has to be a concept of internal and external force, which should be clear to you. Okay. So suppose I'm giving you an example. I am taking a glass of water. This is a glass filled with water, and I have kept it on a table. Okay. Now there's a glass which has been kept on a table. That's it. Now this is the system which is under my study. This table plus this glass is the area of observation for me. So what is this called? This is called a system. In physics, system means the part under observation. In physics and chemistry too, chemistry also you'll be witnessing this. So this is under observation. I am questioning and solving, and this is the area which I'm observing, nothing else. That this glass is kept on the table. That's it. This is the area of my observation. So this is my system. Now, anything in this universe which is present apart from this glass and table, that entire portion of the universe is called the surrounding. So basically, we can say that this system plus this entire universal surrounding, this is making our universe. So the portion which is under observation in our system, the entire environment around it is the surrounding. So this is how a universe is being created. Now, if I say normal reaction is there because this is in contact with the table, so there's a normal reaction upwards and there's a downward reaction, a downward gravitational force. And now there's one more concept. Okay, yes, class. So suppose this is normal reaction upwards, downwards is the gravitational force. And let's say I am pushing this glass. I am pushing this glass on the table. So these are the forces which are acting. Now, class, this normal reaction and this mg, which is acting on the glass within the system, these forces are then called the internal forces. And this force, which I am bringing it from outside, this is called the external force. So you must have heard internal force, external force, internal force, external force. This is the meaning of it. And one more thing, class. If in this internal force system, net force somehow becomes zero, then we say this system is isolated. So you will be witnessing questions in your physics. In an isolated system, this happened, that happened. So you should know what are the meanings of each. Okay, that is what is the meaning. So what have we discussed? Newton's second law. It says that external force is directly proportional to rate of change of momentum. That is change in momentum by change in time. Concept of isolated system, concept of internal force, and concept of external forces you should know. When to use average force, when to use instantaneous force. This you should. Is it clear till here to both of you, Shiza and Laiqa?
Yes,
Yes,
ma'am.
Okay, write it down till here.
Ma'am, rate of change in momentum and change in momentum are the same.
Yes.
Okay.
Excuse me, ma'am.
Yes, Shiza, say.
Ma'am, we use F equal to dp by dt if the time given is specific, right, ma'am?
If you have a time instant, means if I say
Yes, ma'am.
calculate the force at 3 seconds, and if I say calculate the force between 3 to 4 seconds, so instant is there, differentiate, and you yourself will see the equation is in variable form also.
Yes, ma'am.
See class, the formula of momentum is mass into velocity, right? So if I put mass into velocity and I replace this m with mass into velocity, because momentum's formula is mass into velocity, so how can I write it? F is equal to d mv over dt. Now class, in differentiation there's a rule. If the quantity is constant, it comes out of the bracket. Now you have constant mass in your syllabus only of class 11th. Variable mass won't be given to you in this class. When you are preparing for your JE exams, NEET exam, not even in NEET, just in JE exams, if you are preparing, that time variable masses come. Mass constant is there, so mass comes out. Now class, dv over dt, rate of change of velocity, it's acceleration. So you get the equation F is equal to ma. F is the force, m is the mass, a is the acceleration. So this is how F is equal to ma is derived, and this is how you have to write its equation. So it's a vector quantity. What? Force is the vector quantity. SI unit is Newton, CGS unit is dyne. And if you are required to convert Newton into dyne, you can write it as 1 Newton is equal to 10 to the power 5 dyne. Okay, we'll see questions also. Start writing from here. And this derivation usually comes in 2 marks only. See, this is a very basic question. A body starts from rest and attains a velocity of 10 meter per second in 5 seconds. Mass of the body is 5 kg. Calculate the force. So this is a question since we have discussed it in the class, main class only. So that's why the solution is also written. Very easy question. See, mass into velocity will give us the momentum. Momentum divided by time will give us the force. So 5 into 10 by 5, that's 10. Write it. The next question first you will try to solve, then I'll discuss.
Ma'am, in the question, in the end, it says force on the vehicle if mass of vehicle and driver is 300 kg.
Yes, see, it's 300 kgs. It's both the mass. Mass of driver
Okay.
alone cannot be 300 kg. It's
Thank you,
both
ma'am.
the masses are given. See, let me discuss it now. Firstly, you have to identify that this is given in kilometer per hour and your SI unit is meter per second. So you will automatically convert it into meter per second. So very easy question. It looks lengthy. The steps are very, very easy. Okay. So U is equal to 36 into 5 by 18. Always multiply any number with 5 by 18 to get it in meter per second. Okay. So you get 10 meter per second. So V is equal to U plus 80. Now, problem is that we have the initial velocity. But for force, we require mass into acceleration. Okay, mass was given in the question, 300 kgs. But acceleration wasn't mentioned. So other data was provided to calculate acceleration first. Like V is equal to U plus 80 here. If V is equal to U plus 80, then V is 0, final velocity, because the body is stopping. Initial velocity is 10, given in the question and converted. Acceleration is missing, time is also given. So 0 is equal to 10 plus 5a. 10 will go there, so 5a is equal to minus 10. So once you calculate it, it becomes minus 2 meter per second square. Always remember one thing, whenever you have negative acceleration, it is called retardation. So basically this negative acceleration is the retardation, this one. This negative sign. This is the retardation. Anyways, that is not our task. So 300 into minus 2, minus 600 Newton directly. Write it, then Newton's
Yes, ma'am.
third law we'll discuss. Clear?
Yes, ma'am. Done,
Great.
ma'am.
Both of you have written?
Yes, ma'am.
Okay, let me start with the Newton's third law itself directly. C class. Now, Newton's third law is all about action and reaction. Basically, it's very easy. Newton's third law is very easy to see. There's a body A, there's a body B. They are in contact with each other. So whatever is the force exerted on B due to A will exactly be exerted on A due to B. So that's why we say FAB is equal to minus FBA. So the Newton's third law of motion says that to every action, there is an equal and opposite reaction to it. And they are instantaneous process. When I say they are instantaneous process, this means that they occur very, very quickly. This occurs very quickly within a very short duration of time, and a very, very quick action occurs. All right, so action and reaction are simply opposite to each other. So to every action, there is an equal and opposite reaction. Now, instantaneous means it's not like one action will occur on one body and then 3 years later the reaction will come. No, it's instantaneous. Immediately you will get the result. Write this too. Then I'll discuss one case that will help you clarify action and reaction. Walking on a road, that is a very important case which comes in the exam to write. First, you write about the Newton's third law, then I'll discuss it.